Alright, so now let's look at the cumulative relative frequency plot. So, it's used to answer a question about percentiles. Alright, so a percentile is a value with a given percent of observations at or below that value. So, how do we construct it? We mark the boundaries of the intervals on the horizontal axis, draw a vertical scale and mark it with a relative frequency, plot the point corresponding to the upper end of each interval with its cumulative relative frequency, including the beginning point. And then we connect the points. So this is a lot easier to actually just see our value and work through it that way. So, let's look at this one. So, the National Climatic Center has been collecting weather data for many years. The annual rainfall amounts for Albuquerque, New Mexico from 1950 to 2008 were used to create the frequency distribution to the right. So we have the annual rainfall between 4 and less than 5 inches. It has a relative frequency of 0.052, and then it keeps on going through. So the cumulative relative frequency gets pretty easy on here. So at the beginning, where you start off with is just the copy one. The next one, you take the next value and add it to the one previous. So on this one, we end up getting 0.155. Keep adding it, and then we keep adding the next one onto that until you get to the very end. Right? So after you've added all of them up, you end up getting the cumulative relative frequency at the last point. So in this context of this problem, what's the meaning of this value? So what it means on this one is that for 34% of the time, you end up having less than 8 inches of rainfall in a year. And at this point, it means 90% of the time, you have less than 12 inches of rainfall. Alright, now, here comes the big key. This is not exactly 1. Why is it not exactly 1? Well, for this situation, there might be a time that there's something that ends up having rainfall that's bigger than 14. So there is some of those little far outlier stretches that aren't included necessarily in this one. So there could be times that there's more. Some of it also could be just rounding issues later on. But for this situation, because we end up, there might be a very slim chance that you end up having more than 14 inches of rain. So to create a cumulative relative frequency plot, we're going to graph a point for the upper value of the interval and the cumulative relative frequency. So the upper value here is 5, and the cumulative relative frequency is 0.052. So a plot for each, or for the beginning, will be at 4, 0, because 4 is the very starting point, and we always want to start it off at 0. So again, start up at 4, 0 here, right? And then for the next one, we end up moving it up here. So this ends up giving us our relative frequency plot here. This is all the data that we have plotted, and we just connect the dots as we go up. Alright, so one of the questions that might be posed is, what proportion of years had a rainfall amount where there were 9.5 inches or less? So the way we do this is we go to 9.5 inches on our rainfall. We draw the line up, and then if we go over, we can actually see how often that happens. And that's approximately 0.55, so 55% of the time. Alright. Another question might be asked, approximately 30% of the years had annual rainfall less than what amount? So we go to 30 on the y-axis, go down, and then we look, oh, well, that's approximately 7.5 inches. Okay, so when we're looking at this, we've got those values from there. Alright, and then the next question is, which interval of rainfall had the larger proportion of years? 9 to 10 inches or 10 to 11 inches, and we're going to explain. we're going to look at the 9 to 10 inches and the 10 to 11, and notice that the 10 to 11, it was steeper, which means it had to occur more often. So 10 to 11 had more years. Alright,